Last video, we discussed about quadratic equations and a little bit about their roots. But what are quadratic equations again? Quadratic equations are polynomial equations with second degree and can be written in the form of ax squared plus bx plus c. A is the numerical coefficient of the x squared, b is the numerical coefficient of x, and c is the constant term. So a must not be equal to 0 because if a is equal to 0, then this will be a first degree polynomial. Okay, but b and c can be 0. So the roots of quadratic equation are the values of the variable that satisfy the equation or make the equation equal to 0. They are also called zeros or solutions. So we have talked about example problem that where solving for the roots can be helpful. And we have we will discuss three methods of finding the roots in this video series. And for now, we will discuss about factoring. So what is factoring? So a factor pair of an integer is a set of two integers that when you multiply them together, the product is n. So for example, we have the number or the integer 6. What are two integers that when you multiply together, we will get 6? It can be 2 and 3 because 2 times 3 is 6. Another factor pair is 1 and 6, right? Or now let's think, are those all of the pair of integers that when you multiply them together will get 6? Or maybe there's more. Let's think, maybe -1 and -6 because two negative numbers when multiplied together is positive, right? So -1 times -6 is also positive 6. So these are also factors or factors of 6. Another one with the same concept is -2 and -3. So those are the integer factor pairs of 6. For polynomials, we want to express a polynomial as a product of polynomial expressions with a lower degree, right? So it's the same method. So in quadratic expressions, we want to express it as product of two first degree polynomials if possible. So this is foreshadowing. If possible, this is foreshadowing that sometimes there are quadratic expressions that are not factorable. But for now, let's just focus on those we can factor. For example, we have x squared minus 4x. And now we can see that both of these terms have x, right? So we can factor out x. And we will get x times x minus 4. So that is the factored form of x squared minus 4x. So how can factoring help us finding the roots? Let's see. So determine the roots by factoring x squared minus 4x. Again, the factors of this quadratic equation is x times x minus 4. Let's don't forget the equals is equal to 0, right? Okay. So how will we find the roots? Now remember, let's just take a side note here. If we multiply two numbers, let's say m and n, together and their product is 0, that means at least one of them is 0, right? Can we think of two non-zero numbers that their product is 0? I don't think so. So that means either or at least one of them is 0. That means m is equal to 0 or n is equal to 0. And same idea here. These two uh, these two terms here are multiplied together. So we can consider this. Let's say this is m, and let's say x is m, and let's say x minus 4 is n. And we can see they're multiplied together. M is equal to 0 or n is equal to 0. So we can say x is equal to 0 or x minus 4 is equal to 0. So that means x is equal to 0 or x is equal to 4. So we can treat this as two separate equations now, right? And we determine x. So we just copy it here. X is equal to 0. X minus 4 is equal to 0. What is the value of x that will satisfy the equation? We can add both. We can add 4 on both sides. So we'll get x is equal to 4. And we can substitute. We can check. Let's try to check it. Let's try to check it. If we substitute 0, we will get 0 squared minus 4 times 0 is equal to 0. And 0 minus 0 is just 0. So this is a true equation. Another one. Let's try 4. So we will get 4 squared minus 4 times 4 equals 0. So if we substitute 4, we will get 16 minus 4 times 4 is 16 equals 0. So this is another true equations. And these are the only possible solutions for this quadratic equation. You can try other values, but you will get a contradiction. Okay? So these are the two roots or zeros or solutions of this specific quadratic equation here. Okay, let's try another one. So x squared minus 7x plus 6 is equal to 0. Now, unlike earlier from the previous slide, we can easily factor x here since both terms have x. But here, only the first two terms have x. So what can we do if this is the case? So to factor this quadratic expression, we can determine the factors of AC, where if you add them, the sum must be equal to B. So the factors of AC, factor 1 times factor 2 is equal to AC. And when you add them, factor 1 plus factor 2, that is equal to B. So let's determine the factors of 6. Factors of 6. So we already talked about this earlier. We can have 1 and 6, 2 and 3. But when you add these pairs together, we won't get -7. So we can write here, B is equal to -7. And here, AC is equal to 6, right? A is just 1 here. So for this series, so for this video, we'll just talk about the quadratic equations where the leading coefficient is equal to 1. So for here, 1 times C is just C. So we'll only consider the values of C here. Okay, so it's just simply 6. Okay, but remember, we can also have -1 and -6, and -2 and -3. So for this B, -7, to have let's choose from which of the factor pairs here, we can see that -1 and -6 are the factor pairs where when we add them together, we will get -7. So what now? So we can express this quadratic equation here, as, let's put an arrow here, x squared -1, so minus x, then -6 minus 6x plus 6 equals 0. Let's rewrite that. Equals 0. Okay. And now we can pair, it said here, factor by grouping. We can pair the first two terms and the last two terms together. Both of these terms have x, so we can factor x out. So we will get x times, let's write this a different color, x minus 1. And here on the other side, we can factor -6 here, right? So we can get -6 times x minus 1. So why will this be x minus 1? Well, we can see Negative 6x divided by negative 6 is just x. And positive 6 divided by negative 6 is just negative 1. So we'll also get x minus 1 equals 0. Let's just copy that. And now we can see that both of these terms have x minus 1. So now we can factor out x minus 1. So x minus 1 times x, this 2 here, x minus 6 equals 0. Okay, we considered x minus 1 as one object, then we factored it out. Okay, so x minus 1 times x minus 6 equals 0. And we have the factored form of the quadratic equation over here. So what now? Again, if we have two numbers that are multiplied together and their product is 0, so at least one of them is equal to 0, right? So that means this over here, x minus 1 is equal to 0, or is the other one, or x minus 6 is equal to 0. And let's treat these two equations here as two separate equations, and we can see x minus 1 is equal to 0. What is the value of x that will satisfy this equation here? Well, x is equal to 1. We can add 1 on both sides. Okay? And how about this other one here? X minus 6 is equal to 0. Well, we can have x is equal to 6. We can add 6 on both sides and we will get x is equal to 6. And these are the two roots of this quadratic equation, x squared minus 7x plus 6. Okay, if you have any question, you can just comment down below. Now, let's find the roots. Let's try more examples. That's how we learn. Let's try more examples. X squared plus 2x minus 3. Okay, so if you ever want to try, just pause and you can try, but I'll just continue here. So factors of 3 or factors of negative 3 is AC, but our leading coefficient is just 1. So we'll consider C. Factors of negative 3 are negative 3 and 1, or the other way around, so 3 and negative 1. So which of these two factor pairs, when you add them together, we will get 2, right? So that is 3 and negative 1. Okay? So let's see. From the previous example, right? The factors of 6 here that we used are negative 1 and negative 6. And the factored form here is x minus 1 times x minus 6, right? Okay, we won't prove it, but there is a pattern here, at least for when the leading coefficient is 1, right? There is a pattern here that the factors, you can substitute it here. So for example, the factors are, let's say, again, m and n. Let's just use m and n, right? If the factors are m and n, so we can just write x minus m times x minus n. So that is the idea, okay? So we'll see here. So since the factor pairs that satisfy that when we add them together, the sum is 2, we can just say this is also x plus 3 times x minus 1 equals 0. So this is already the factored form of our quadratic equation. And again, so now we'll find the roots. So that means x plus 3 is equal to 0, or x minus 1 is equal to 0. Just put separator here. Okay. And lastly, we can determine the roots. So that is x is equal to negative 3, or x is equal to 1. Okay, okay, let's try another one. X squared minus 2x minus 3 is equal to 0. Now this is just, it's almost the same as the quadratic equation over here, but we have a p which is equal to negative 2. So that means the factors is negative 3 and 1. So we can write this as x minus 3 times x plus 1 equals 0. And same idea, same concept, x minus 3 is equal to 0, or x plus 1 is equal to 0. So we will get x is equal to 3, or x is equal to negative 1. Now let's just put the word or here. Yeah, okay. And these are the two roots of x squared minus 2x minus 3. And you can double check it by substituting, and this left-hand expression, this left-hand expression here must be equal to 0. Okay, let's try another one. Let's try more. X squared minus 25 equals 0. Now, let's see. What is the value of b here, and what is the value of AC, or just C? So we can see that the value for C is just negative 25. Right? So this is the value for C. But B here, the B here is, we don't have B, right? But remember, we can just rewrite this as x squared plus 0x minus 25 is equal to 0. So that is the reason why we don't write B, the term x, right? B times x here. It's just because it is multiplied to 0, and it will be canceled, right? 0 times any number is just 0. So our B here is 0. So let's determine what is, or what are the factors of 5 that when you add them, factors of negative 25 that when you add them together, we will get 0. And that is just, you can list again, but we'll just continue, and that is x minus 5 times x plus 5 equals 0. And now, just like earlier, since these two expressions here are multiplied together, that means x minus 5 is equal to 0, or, or x plus 5 is equal to 0. And now that means x is equal to 5. This is one of the roots, or x is equal to negative 5. And these are the two roots of the quadratic equation. Okay? And there is a pattern here. So when b is equal to 0, we can see that there is a pattern that these are just the sum and difference of the square root of the first term and the square root of the second term. So if we have x squared minus 1 is equal to 0, again, b is equal to 0 here, we can directly write this as x minus 1 times x plus 1 is equal to 0. And again, with the same pattern, x minus 1 is equal to 0, or x plus 1 is equal to 0, and x is equal to 1, or x is equal to negative 1. Let's write or. Okay? Let's try more. So x squared plus 4x plus 4. So what are the factors of 4 that when you add them together, we will get positive 4? Again, you can write it on your paper, but we'll just continue. These are 2 and 2, right? So we can have x plus 2 times x plus 2 is equal to 0. And this right here, we can just say, since these are both the same, x plus 2 and x plus 2 are the same terms, same expression, we can just write it as x plus 2 quantity squared is equal to 0, right? And here, we can say that x plus 2 is equal to 0, And the root for this equation is x is equal to -2. Again, we can try again. We can try the same method as earlier. We can have x plus 2 is equal to 0, or x plus 2 is equal to 0. But again, these are just the same equations. So we will get x is equal to -2 or x is equal to -2. We just arrive at the same equation, right? So no need to write extra. We can just write x is equal to -2. Let's try another one with the same pattern. X squared minus 6x plus 9. Again, we can write this as x minus 3 times x minus 3 is equal to 0, or x minus 3 squared is equal to 0. And that just means x minus 3 is equal to 0, and the root is x is equal to 3. And you can try to find other roots. Good luck. Okay. So let's try this equation 2x squared minus 3x plus 1. But now you can see that there is a leading coefficient of 2. A is not equal to 1. So this will be the topic for the next video. And now let's just look on the factors that we have split. See you on the next video.